Right, so this video is about the mean value theorem, and so what the mean value theorem is basically an extension of Rolle's theorem. So if you remember with Rolle's theorem, you have 2 points, and they're both exactly the same y value. Then the slope here is 0 between these 2 points, and that means that there has to be some c value where our derivative would also be 0. Well, if I take that point and I kind of rotate it down, the same conditions still happen. So right there we have now a slope of this line as being 0.476. There still has to be some c value in there that would give us a line that's basically parallel to it, giving us the same value. So that's what the mean value theorem states, is that if you have 2 points, the slope of the line that they make, there has to be some derivative with that exact same value in it. So like this, you have some point here, and this is a comma f of a, and this point would be b comma f of b. So if you have a nice continuous function and you're connecting them from here to here, you can either go up like before, or down, or straight across. But what you're going to end up creating is, no matter what, there is a parallel line that your derivative can create. So that derivative is going to equal whatever the slope of this line is. And so that slope would just be y2 minus y1 over x2 minus x1. So this situation. So if we have f is continuous on a closed interval, so we have a closed interval here ab, and it's continuous, and it's differentiable on that interval as well, then there has to be some tangent line in there, right, f prime of c, that will equal the slope that these two lines create. So let's look at an example of this to show you what I'm talking about. So we have this function, and yes, it's discontinuous at 0, but that is not within our interval. So part number 1, our function f of x is continuous on 1 comma 4, because remember, it's a rational function, so rational functions are continuous on every point that they are defined. It's just not defined at 0. So it is continuous on 1, 4. Check. F of x is also differentiable on that interval. So because this is true, therefore, we know that there has to be some f prime of c equal to our f of a, so our f of 4 minus f of 1 over 4 minus 1. That it equals a slope. So what we're going to do first is we're going to take our 2 points here for our graph. I've already graphed it. We have 2 points here, and we're going to draw like a little fake line in there. And what we're going to do is find that slope. Okay, so let's find f of 4 first, and then we'll find f of 1. So we're going to plug in our x values, our x sub 1 and our x sub 2, into our function to give us our y sub 1 and our y sub 2. Okay, so this is 5 minus 4 over 4, which would be 4. And this is 5 minus 4 over 1, which would be 1. So we end up with a y sub 1 of 4 and a y sub 2 of 1. So those points then would become 4 comma 4 and 1 comma 1, which is what we have on here. So we have our 1 comma 1 and our 4 comma 4. So what is the slope of that line? That would be 4 take away 4, and 4 take away 1, and 4 take away 1, which would be 3 over 3, which is 1. So if the slope of this red line right here, this dotted red line, is 1, then according to the mean value theorem, there must be some other tangent line on there that also has a slope of 1. And you can tell it's kind of there. If I draw a parallel line to it right there, you can see these two lines are parallel. So that means this derivative here would have to equal 1 at that point, because that's the slope of those 2 points, that line created by those 2 points. So if we take our f prime of x, that's what we need to find next, and we set it equal to 1, it will give us our c. So if I rewrite this as 4 minus 4x to the negative 1, that would be 0, and then 4x to the negative 2, which is 4 over x squared. So now what we're going to do is use what we said. So we know that this is equal to 1. So we're saying f prime of c is equal to 1. So if I plug in a c value, this would be 4 over c squared. We know that this has to equal 1. And that gives me my equation. 4 over c squared equals 1. And so we get 4 equals c squared. Square root, plus or minus. So our c is equal to plus or minus 2. So we have to make sure that we stay within our closed domain, which is 1 to 4. So if I plug negative 2 and positive 2 into 1, 4, the only two that would fit in that value, that range, that domain, is c of 2. And that matches. So there's our c of 2. We follow it up. Perfect. It works perfect. So that means we can come up here now and erase the c and put in a 2. And that is the mean value theorem. So if you have 2 points, you take the slope of them. If it's continuous between those 2 points, then there has to be some derivative in there that will also equal the exact same slope that you found here. And so there's our answer.